Welcome to Corpstruction, a show about science, technology, engineering, and math. This episode is brought to you by the U.S. Army Corps of Engineers, Tulsa District. I'm your host, Brannen Parrish. Today I have with me three engineers from the Dam Safety Production Center, Adam Smith, Jeff Stevens, and Daniel Morales. Welcome. First of all, gentlemen, thank you for taking time out of your busy day to join us. If you don't mind, go ahead and introduce yourselves because we have multiple people here being interviewed.
Yeah, so Adam Smith, civil engineer with the Dam Safety Production Center.
Jeff Stevens, geotechnical engineer, also with the Dam Safety Production Center.
And Daniel Morales, structural engineer with the Dam Safety Production Center.
So one of the projects we're working on right now is a VA hospital in Muskogee, Oklahoma. Tell me how the Corps of Engineers came to be involved in that project and what it is we're doing.
So I think it was 2015, the hospital at Muskogee had a landslide. They had previously contracted out a job to install a generator building, and due to an incident at the site and some heavy rainfall, it led to a landslide. They had to do an emergency fix of the slide, and it had sat for a few years. Catherine White contacted me, and we did she had been contacted by the VA hospital because they were curious kind of what the status of the hillside was. So we did a slope stability analysis of the hillside and determined that while things were stable at present, there was the potential for future issues at the site. The VA had done a contract, or at least a partial design build kind of contract to fix that, and we looked at their package and decided that it was not going to be adequate to provide long-term stability and achieve the goals that the VA wanted to do. So the VA went ahead with the Corps, and we came up with a conceptual design package, presented that to them, and then at their request pursued that all the way through a full design bid build package.
You mentioned the hillside was saturated somewhat. What are the implications for a hillside, especially with a retaining wall that is saturated with water?
So it wasn't just the rainfall. There was, because of the excavations that had been occurring for the ongoing contract the VA had at the time, they went ahead and put a surcharge load on that slope as well. So that when you put an additional load on the slope, then it reduced rainfall to basically led to a buildup of pore pressure in the soil, and it led to a slide. We did some analysis during design at the request of one of our value engineering study comments to kind of do a forensic analysis of the slope, and we just determined that looking at the geology, there's like a layer of clay or highly weathered shale right at an interface, and we think that in that layer is where we had the buildup of pore pressure, kind of a sliding failure, and the soil went over the hill.
What's a surcharge load? Can you explain surcharge? Would you call it surcharge load?
Yeah, Daniel, if you want to take the surcharge question, that kind of gets into some of the structural aspects.
It's just really any external load applied to the soil or foundation. It can be, from vehicles, like Jeff said, construction equipment that just sits and kind of imparts a pressure, if you will, on the soil, and then that'll translate through and find the weakest area, and if that weak seam, like Jeff said, is not strong enough to create enough friction to resist that force, it'll just cut right through that material and then cause the material to move and create an instability, really. So
yeah, if you think kind of like an avalanche occurs, generally you'll see a snowpack on a mountain, and additional snow that comes that's not part of the initial fall can create a surcharge weight that occurs at the top surface, and that can result in a cracking motion, a sliding motion between the underlying plane and the overburdened plane, and then you'll see kind of like an avalanche effect. And so that's what the risk was of occurring on this particular slope. The initial response that I guess the VA had was to try to shotcrete with grout the face of the slope in order to reduce, I guess, the risk of outlet points for rainfall that infiltrated into the foundation as a result of rain.
So let's talk about the project now. What are we doing in terms of that overall project?
Yeah, the big thing that we're doing is stabilizing the soap. That's the main important aspect of the project. We want to make sure that the VA hospital remains in a stable condition just beyond where the slide occurred. And then additionally, as a secondary benefit that the VA will realize is additional parking stalls. Right now, they actually contract with a third party for vehicle transport, or I guess personnel transport from a contracted parking area that's off campus. And so what that does is it increases commute times and for personnel. And what this does is it offers a secondary benefit of having everything co-located so that personnel can be right on site next to their vehicles in the event of an emergency or in the event of a late morning or something like that. They don't have to take the bus back to the campus. And so we've got a number of structural features and geotechnical features that are part of the project, including principally a buildup of material that we're going to do for a work platform to install a soldier pile wall system. And Daniel can talk about the more of the design feature related to the soldier pile wall. But then additionally, we create that work platform that will eventually be utilized as a parking area. And then around the perimeter of that, we've got mechanically stabilized earth, or MSE, wall systems that surround the perimeter of that, and then an access road, some instrumentation, settlement monitoring, as well as some on-site water detention systems so that we can treat any storm runoff so that we're not increasing the impacts to the city of Muskogee. So Daniel, if you want to maybe talk about the soldier pile wall system.
I mean,
it's a pretty complex system.
Jeff and Adam mentioned, it's really, one of the primary purposes was really to stabilize that area, that slope behind or next to, adjacent to the hospital. And one of the ways you can do that is through installing a structural feature like a wall system, a retaining wall system that accomplishes trying to hold back and prevent soil from moving and failing. And if you have an unstable slope, installing a wall system, a structural wall system like that will keep that material retained. And so that's part of the process, is installing the tieback wall system, which is soldier piles that are embedded in concrete, drilled into the foundation, to the bedrock at a much lower elevation, and those are spaced a certain spacing, and then timber lagging is held up as you excavate and reveal and expose the retained earth, and then you follow up with that with drilling in high strength post tension cables that go back into the much further beyond into the competent material, and rely on that to hold that wall system in place, and actually install the similar system at the site. It's at the upper hillside of that slope, and it had success with that system, and so that's the similar type of system we used here. But then we went a little bit beyond that, because the parking lot, it kind of evolved, and as we became aware of what the VA wanted in terms of the parking spaces and size and so forth, we had to put in another secondary wall along the bottom part of the slope. It's an MSC wall, as Adam mentioned, a mechanically stabilized earth wall, and just composed of precast concrete panels that are tied back with geo grid reinforcement, and it doesn't corrode. It's installed, and it's really permanent feature.
Why is that geogrid? Can you talk about why that geogrid is so important to I mean, even any potential retaining wall, having geogrid is huge. Right?
Yeah. Oh yeah. I mean, it's like it's really. It's a primary component which holds those panels in place, and and you go out and you see mechanically stabilized earth walls all over town. I mean, you go see them all across the city, right? And really all you see is the facade to the wall, like stones. They can be stones. They can be, sometimes you'll see on the sides of highways, you will see a concrete face wall.
Concrete face fall with a fake stone facade.
Yeah,
because
exactly. I
they-
mean, and you can get as exotic or as, you know, aesthetically pleasing as you want, right? But what you don't see is behind that wall system is really what the main structural feature holding that back is those geogrid system, or sometimes they'll use steel reinforcement to hold it back. But
Is that like the steel reinforcement you use in concrete? The
it's
strength
similar
of
to it,
concrete?
yeah. Sometimes it is
Like a
used.
grid, steel
Sometimes,
grid?
sometimes they use that as well. In this particular site, we're using more of the geogrid system. It's geosynthetic materials that do not corrode. They still offer a lot of strength as what you need, as what would steel reinforcement mesh would provide, but they just do not corrode. So they can be buried and have a very long service life without really any concern of trying to go back in and trying to replace that. But it's really specific fill that goes in there, and what happens is as the earth pushes against those panels, those geogrids are embedded back into the material, and there's friction that's created across the earth, and that's wedged in between these reinforcement grids, and that's what's holding back those panels from just falling over, falling
So
forward.
it adds additional strength, right, on
Oh,
top
absolutely.
of what you would
It's
get
a
normally
system.
with the retaining wall.
Yes,
right?
it is. There's some redundancy in that way, because, you know, if it was just a typical retaining wall system that's just by itself, it just sits there, and by gravity alone, it sits there and stays there. You know, there is redundancy in the system because of the reinforcement mesh and so forth, but it's a little trickier. I mean, it's more specific because, you know, that fill that goes behind this type of a wall system, it's very specialized. It's got gradations. It's got certain properties that's got to meet. You know, and so it's a little bit more unique in that way. But
Well, and
yeah.
two, the benefit that we realized with the MSE wall system versus a gravity system is your cross-sectional profile, your depth of the wall into the grade significantly reduces. And so what you have then is an ability on the exposed top surface to extend for additional parking or circulation space. And so you have all of the strength benefits while also then realizing additional opportunities for utilization of the surface. And that's different than a gravity wall system
yeah,
would
you'd
provide.
have to excavate much further back beyond the wall to actually build that wall system, and all these wall systems that we're using, the tieback wall system, the MSE wall system, they require much less of a footprint to build, and the tieback wall especially, because it's more of a, you drill down into the earth and you build the wall system, and you start to expose it, you know, and you create that vertical face, and you don't have to really go and encroach into the, you know, like as much the foundation of like the hospital. So you use those wall systems in these situations where you're very close to, you know, buildings and structures around, and you don't want to encroach on those foundations. So it's more suited for, you know, this site and so forth.
So when you guys use, because you're using like the jargon, right? The
Mhm,
engineered
right.
construction jargon. You say mechanically. What is it? Mechanically
We stabilized
stabilized
Mhm.
earth walls. Yeah.
And that essentially means the wall, the
geogrid,
geogrid,
the engineered fill.
the engineered fill. You also have a drainage system, right? I
Mhm.
imagine you run the drainage pipe on some kind of a, what is it? Washed? Is it called washed gravel? Washed?
Yeah, it's
washed media or
generally a filtered,
Yeah.
aggregate. Yeah,
aggregate.
yeah, yeah, rock.
So
Yeah,
rocks.
rock.
Yeah, exactly.
Yeah.
So what, like, and that's important too, right?
Yeah.
Because
Mhm.
water is heavy.
Absolutely.
So how does that impact it too? Because I guess the geogrid allows liquid or water to
Mhm.
flow down through the structure, right? And then you have a essentially
collection
like a
system.
drain.
Yep.
Yes.
Yeah, and Jeff, maybe if you want to talk to that a little bit about the really behind the wall system, you know, like you were saying, the pore pressure gets reduced because, you know, we're relieving the stress that's a result of that pore pressure through a drainage system through the wall, and you know that's kind of a soil structure interaction is what we would refer to that as. But if you want to talk a little bit about, draining the foundation behind the walls.
Yeah, it's very important to keep the water out from behind the wall, because otherwise, essentially, you're kind of building a dam type structure and adding to the stress on that wall.
Can you say that again? I'm sorry. Can you start over on that, what you just said?
So if drainage is very important behind a wall, obviously, because otherwise you're sort of building a dam for your groundwater. It would build up pressure on your wall and increase the stress and increase the likelihood of a failure, which, Daniel in his design would certainly account for a groundwater table that would rise as a result of rain. And, you don't always want to account for your filter and your drainage system being 100% efficient, because it won't be in the field. So, but it's very important to have that. And another element of the design that really hasn't been discussed as far as drainage and all that is the fact that we're removing a lot of very unstable soil media. The VA historically at the site had used it as a construction debris disposal area. So you essentially had a hodgepodge of soil, bricks, concrete debris.
What does that mean for when you're saying you've got a hodgepodge and it's not? I mean, it's not necessarily the best material to have in there. What happens with stuff like that when you have different inconsistent types of material or different consistencies, I guess?
Yeah, homogeneous.
You have a diverse set of materials.
It makes design very difficult just because there's no textbook property for it. You can guess. And also you can have voids in there. You could have differential settlement. So, you build a parking lot on it. Part could settle because there's been a void under it. So you park a car on it and it could settle.
Sinkholes.
Yeah, you could get that kind of action.
Yeah.
You could see a preferential for like a landslide if unstable material.
Because that's not something people really think about. I mean, and there's is there like a mathematical formula you guys use when you're trying to figure out based on the type of material you have? What is that where you take? I mean, is that where core samples come into, and so or you have an idea of what your earth or aggregate or whatever is?
Yeah. So actually, that was one of the important things when we were doing design last April. Is we actually had a drill crew from the Omaha district come out. I think it was Omaha. Omaha district came out and drilled 4 test borings. We had historic data from the VA, but we weren't entirely, the Corps hadn't been involved with it. We were unsure of, the processes used. So to ensure that we had good quality control and the data was what we needed, we actually had 4 test holes come out. We did some sampling of the soil media on top as well as the rock. But the rock was the most important because it gave parameters that were essential to structural design and verifying that we were making sure the rock was as strong as we thought it was.
And at the location, the depth that we needed it to be. You don't want to for sure found a structural system on a non-competent foundation material. You want to get into that competent bedrock so that we know that we've cut off any risk of sliding, above that, end condition for the wall system, and that ensures long-term longevity of and security of that system.
What's challenging about taking over a site like that and because you have to do a lot of the design, right?
Correct.
Are you still using AutoCAD? What are you using?
Yeah, we still utilize Bentley MicroStation. There's multiple sub platforms within that we utilize. For instance, on this particular project, we utilized Inroads Select Series 4, but the Corps and Bentley have since moved on to a new design subroutine there called Open Roads Designer. And basically what that does is it allows us to create surfaces that we can then manipulate in our design process to show the contractor our intent for subsurface grading, temporary construction features, finished grade conditions that we want to represent. And then that also allows us to gather between individualized surfaces quantities, and so we have a lot more precision in our quantities as a result of some of those types of software packs. And from our perspective and from our engagement with the VA, there's a lot of eyes on this project. It's a very important project because it's been a very critical area immediately adjacent to the main hospital. And interestingly enough, the main director of the hospital's office overlooks this project site, and so there's a lot of visibility, and so that's why we're working heavily with the construction staff on site and in the Tulsa resident office to make sure that submittals, requests for information, weekly meetings, and all that the dialogue remains very much open, and we've had a really good experience with the construction staff out there. We'll make periodic site visits to ensure that any of the critical features of work are being constructed as designed, and then we'll engage periodically with the VA staff themselves, who are overseeing the engineering side of that environment to let them know that everything's progressing as designed, and there are no identified issues that we've had to date. So.
And now, is there a separate project with clearing a bunch of land, or is that the same? Is that part of the same?
Yeah, that's also included in this. The main reason for that clearing, which we did a lot of coordination through the environmental and regulatory offices to make sure we're in compliance with ODEQ standards as well as our core regulatory standards, and the challenge with having this hillside is that there's limited access on the upper slope. You've got deliveries being made to the VA hospital all the time. You've got a new generator building that's going to be constructed on the upper hillside. And so really there was going to be a lot of congestion up on that upper slope. In addition, there's just limited circulation space because there's primary parking for patients and staff up on the upper slope as it is now. So what we're doing is we're limiting the contractor to the access being from 48th Street. And what that does is, number one, provides a long-term access route to this parking area. It also benefits the city because they have platted out for future potential development some areas for residential construction, and it allows for that infrastructure to be set in place earlier than expected, and it reduces that congestion that our contractor could potentially experience on the upper hillside. And so there were multiple considerations for alignments, widths, and we had for sure to comply with city standards because this was going to be a long-term piece of infrastructure that eventually the city would probably take over. And so we had to do a lot of coordination with various entities to make sure that we're meeting all those different standards. And so, so the kind of forested area that was previously down slope, if you will, over to 48th Street is getting a narrow corridor of clearing so that we can put that new access road in.
Are you getting good feedback from the city about or have you been? I think you said you've been in contact with them.
Yeah.
Right? So are you getting good feedback from them as far as?
Yeah, the clearing activities so far have just commenced within the last 2 to 3 weeks, and so there's a lot of that going on right now. Initial grading of the site to meet our slopes and roadway conditions for long term, but really the road isn't going to be constructed until near the end of the project because we don't want to degrade a newly paved road with construction equipment. And so they'll put down a temporary access and then come back and improve that at the end of the job. But we haven't heard any concerns or issues from the city, and it seems like all of the traffic control and safety procedures that the contractor has in place currently are meeting any of those city guidelines as well.
So this is technically, I guess, a MILCON project, right? Military construction.
Yeah, it's kind of like, I would actually refer to it more so like a major maintenance project,
okay.
Because the project site was already existing at the time, and really we're improving or restoring, if you will, the existing slope. The benefit is, in order to do that, we will create this parking area and access road to be able to handle the construction of this restoration. But I I don't believe it was actually programmed under a 1391 document like a normal MILCON would have been done. So
It's just not a civil works.
it's definitely not a civil works project.
No,
Yeah,
it's
yeah, yeah. There are definitely civil works, conditions that we would consider, but no, it's more so more of a vertical. I would say more of a vertical construction type project that you would normally see on an installation.
Are you guys all normally ENC, or do you normally follow DSPC, or?
Yeah, all of us are Dam Safety Production Center employees, and the benefit is, Daniel and I we've been in the district for almost 20 years now, and we came from the ENC side of the house. Jeff came on, was it as an entry geotech, and then you've progressed up the ranks as well over the last few years, and so we've had a lot of contacts. We've got a great network of ENC staff, particularly on the construction side, because that's who we're dealing with at this point. And so the relationships piece, Brannen, you and I have talked about this in the past. Relationships are everything, and they really help with expediting any concerns and resolutions, as well as keeping tabs for us on what's going on site, as well as in the programming side, making sure that we're not busting budgets or schedules, those kinds of things. And so relationships have been everything on this.
How is doing a retaining wall similar to levee type work? How because there are some similarities to a degree. You've got to have a drain and
Right. Yeah. Generally, a lot of the features that we're doing on this VA project, we would utilize the principles on a civil works type project. So you'll have embanked fill, compacted fill. You'll have drain or filter materials. You'll have generally some sort of structural system, whether it be like a kind of a structural cutoff wall through an embankment, or if it's going to be a concrete, reinforced concrete outlet structure, those kinds of things.
So,
you'll have access and traffic,
let me interrupt you. Sorry. When you say cutoff wall, can you explain what that is?
I'll let him explain what that is.
Yeah, because I hear these terms
Yeah,
all the
yeah.
time, and sometimes when I hear cutoff wall, I'm thinking, I
Does
have
it do?
no idea how to even picture it in my head sometimes.
Yeah.
So.
So Jeff, you're aware of what a cutoff wall is and how that interfaces with the embankment material.
I'll do my best to
Yeah,
explain. So basically, a cutoff wall would be sort of a structure you would place through the middle of an embankment.
Yeah.
It could be a mix of like a slurry with a concrete soil mix. It could be a sheet pile wall. There's different methods of it, but the general principle is to try to cut off seepage through the embankment, and to either force that seepage to go deeper, which increases the length of the path for the water, which decreases its potential for, it decreases the forces which could lead to failure, or to entirely cut it off and prevent it from going downstream.
And it runs. So when you have this, it runs vertically
Yeah.
into the
Yeah.
the.
Yeah, if you picture kind of like a ham and cheese sandwich, your bread is the embankment on either side, and then your ham and cheese would be the cutoff wall in the middle. So your mustard is not going to get through the ham and cheese to the
But
other side.
But is it laying horizontally or
No,
vertically?
it's definitely vertically. Yeah, it's a vertical sandwich. So
Okay. What are some of the main differences? Obviously, you don't typically
right.
have.
Yeah, generally you're not going to have a soldier pile wall system running vertically through an embankment, or have it maybe even on the downstream side of an embankment. You would construct your embanked fill to be satisfactory condition to to handle any stability and any seepage conditions that a dam or levee would experience. You're frequently not going to have major clearing that you're going to have to do on an embankment. You shouldn't, at least, because of the regulations that we've got in place. There's a vegetated clear zone beyond the toe and the heel of a dam, just because you don't want root systems to encroach into the competent fill, and then if they die off, create a path for seepage to occur. So, and then we're generally not going to create parking lots on the side slopes of an embankment or a levee either. So there are some differences, but there are a lot of similarities, and mostly, like I said, in the way of the compacted fill condition, the drainage condition, the filters, and we haven't really gotten much into the instrumentation side, but long-term piezometer monitoring, settlement pin monitoring that will be available on the tops of walls or just on the inside of the back side of the wall to monitor groundwater and to monitor settlement conditions that may or may not occur in the future.
You won't have that issue with a retaining wall where you need to have
Well,
a piezometer check, right? I mean, you're not going to
Yeah.
have to go do piezometer checks on
It's just not on the same kind of level, really,
Right.
because with dam safety world, really one of the biggest differences too, that besides what Adam mentioned too, is, the water element, right?
Mm-hmm.
Water produces all different types of forces on a structure, right? And from a structural standpoint, you take a wall that's in a parking lot in a, commercial area or in a hospital setting like this, it's not going to be subjected to the same types of forces from water that you would near a dam. That's going to flood. That's
Mm-hmm.
you have flooding events where the water levels, they go up and down, and sometimes they can produce high dynamic forces from the water against you handle forces from the water, from groundwater and things like that. You have those no matter where you're at, and you have to deal with them, but it's just on a whole nother level whenever you're at a dam site with actual water flowing down a channel, or in a lake with varying levels, and the uplift that it produces underneath the structure are much different, right? And it's similar to, as we were talking about, the cutoff wall system, seepage underneath an embankment. Those forces, they cause uplift. They actually push up against this, soil, and can create an instability, and they're just a whole different ballgame, and they actually require a lot more constant monitoring. To get into what Anna mentioned about the piezometers is, at a lake, whenever you're constantly controlling the levels in that lake or a river system, a lock or whatever, they're always varying. So you really need to understand that, in any second, as soon as those water levels change or a flood is coming in, you have to know what's going on with the structure too. And it's best to do that by instrumentation. So that level of instrumentation that we would do for a dam, just on a whole nother level in terms of, this setting where, we're not, we don't have,
Constant
basically a
pressure from
flood.
water on
Yeah,
it.
we don't have a flood coming through,
Yeah.
And if we did, then it wasn't,
I
we have
imagine
bigger
even
problems,
on
but,
the slope
yeah.
side where
Right.
there's not even
Yeah.
there's not water or anything on
Yeah.
that side.
Yeah,
Yeah,
I mean there
right.
could be groundwater
Yeah, there's
through the
groundwater
formation,
But I mean, it's not-
but it's not a
it's
wall.
not the river
It's not,
pushing
no,
it.
no,
Yes,
exactly.
exactly. You don't have a lake, you
yeah.
don't have a river,
Yeah.
you don't,
Yeah.
you're not controlling the flow in that kind of manner. So
Yeah. And
all
e-
those things kind of go away. somewhat.
And even currently, the site is experiencing direct infiltration from rain. So
Right.
as soon as it hits the slope, if it's not saturated, you'll see some water infiltrate into the soil. Well, with this new system we're putting in, we actually have collection stormwater systems that we're putting in, diverting that ground or that surface runoff around the side of the wall systems and down slope. And so the slope will experience groundwater continually, generally because through formations, but it's not going to experience the same level of inundation and saturation as even what it's experiencing today.
Do you see that water exit, or is it usually covered, or do you actually see the point where the water exits?
Yeah, you can.
Okay.
Yeah,
Absolutely.
yeah, and generally at those locations, you'd either have some sort of a rock dike or a ditch, lined condition just to prevent long-term erosion at that localized area, or you can have pipes that connect that groundwater collection to a stormwater system or something like that. It's not required to go to a collected sanitary sewer or anything. It's just stormwater. It would be considered, as soon as it comes out of the ground, now it's stormwater, regardless of how it got there. And
I was
so-
just trying to think if I've ever seen a retaining wall and I've ever seen where the water's coming out on the side or whatever,
Yeah.
where the drain is, and I can't remember if I have.
Yeah, most of the time
Well,
it's
It's up
there's
the
a little
hillside.
bit of a delay. You could look
Yeah,
on
yeah.
the sides of abutments for bridges on highways, and but the challenge is you got to time it right because that granular fill for the
Yeah, it's
drain
going through a
system
screen,
it goes
essentially.
but it's also going through pretty quickly, and
Yeah.
so and earth, like what Jeff was talking about earlier with pore pressure, your particles in an earth fill are extremely small. For particles in a gravel drain system, particles are much larger, so the pressure is released faster and it flows through very quickly. And so even in like a rain event for an area that has a drain system next to a highway, for instance, you'll collect that runoff and discharge it into a subterranean pipe. But then any infiltration that occurs behind like an abutment on a bridge, on each side of the bridge, that has a drain, it may collect for a few minutes after, and then it will have outletted. So there's a very small window to be able to see that kind of stuff. What is interesting is, even during construction on some of our projects we've done before, watching outlet groundwater, it's very clear because it's filtered through the foundation, it's filtered through a porous filter medium, and so it comes out very, very clear, or you hope it does.
Would you? Yeah, you're hoping it. If it's cloudy.
If it's cloudy, then you have some concern about taking material from the embankment with it. But
How do you guys learn to do this stuff? I mean, because I don't know if you had a lot of construction experience before you went to college, or whether you were kind of around it, or you graduate from college, you come to work. How do you learn to do this stuff? I mean, are you? Is it just OJT? I mean, in terms of your training.
Yep, on-the-job training is really critical. I prefer to consider it kind of like an a la carte menu, if you will. Get with people who are mentors of yours, more experienced engineers. Talk with them about the experiences that they've had and start making a list. I've never done a filter design. I've never done a roadway design. I've never done a structure, a wall structure design. And then you can get into some specialization. I've never designed a cement bentonite cutoff wall. I've never designed a two-stage filter. I've never designed, what do you call it? The soldier pile wall system. And so what you can do is you can start, just making a list of those a la carte items as you encounter them, and then find the experts in the Corps, find the experts in industry. We've actually contracted in the past on other projects with, people in industry who are very knowledgeable on things. And then, for software systems, most of the time those manufacturers or developers offer a set, training systems. YouTube's a really good aspect for things. I've spent many a night looking up YouTube videos on some of the Bentley training when the helplines closed. Again, back to relationships. It's all about, identifying those in your network who have that knowledge that you want to seek out, and then they're going to have recommendations for any type of organized training. They'll have recommendations on projects around the country that, maybe you can just go and visit a construction site, not even within the Tulsa District or SWD, but maybe there's a project in Sacramento District. They have a lot of big dams out west. And if you've got a chance to go for a week or two, you can gain a lot of good insight from project engineers on the ground, seeing what they're seeing. And so, I don't know, guys, what do you think?
Can I go next?
Yeah. Do you have any other recommendations? You're newer to the Corps, and so you had probably drinking from a fire hose the last few years on training and learning on the job, dewatering stuff that you've done.
Yeah, I think Adam's right with, relying on, kind of learning from others and other projects. And I think, school gives you going through a bachelor's and even a master's degree gives you a very good toolbox on how to do these problems. Or especially in engineering, I kind of liken it to a way of thinking. You know, you may not learn how to do, say, a 2-stage filter in school. You may do it, but it gives you, you know, you may do a project that's similar or a way that's similar, so you at least learn how to think about it. Gets the problem-solving mindset, and then knowing where to look for resources, whether it's print resources, internet resources, people resources.
So do you just like learn through the process of working on projects that I have this situation occurring, these are the actual tangiable products or type, like geotextile fabric. I imagine you talked about that in school, but you, are some of those things that you learn through the process of just doing it? You're like, oh my gosh, I didn't know that's how we would solve that problem.
I mean, as soon as you're tasked with like taking on a project, you know, and like you're a lead or you're kind of more in charge of something, some element, you know, I think as engineers in general, I mean, for the most part, we dig down into the weeds, and you know, if we didn't know something about that, you're sure by the end of that project we've thoroughly researched it to heck, you know, and it kind of translates into how we are as people, you know, in everyday life. But we engineers in general, we just research topics, and if we were not familiar with them initially, you know, by the end we are. And I think that is just part of the process for any project. But you're right, it does stem from getting tasked with leading a project, and then, you know, then something kind of takes over you as an engineer, and go, you know, that inquiry for knowledge of, okay, how do you do this? Okay, how do what's the industry say on, you know, what are there codes, are there guidelines to do it, right? And you start figuring out all of those, you know, limits to what you need to, you know, put. And like Jeff said, I mean, you take the fundamentals that you learn from school, you know, all those engineering fundamentals, they stay with you, and they do help you to understand how to just solve problems in general. But you know, some of those engineering concepts and fundamentals that, you know, they are critical that you did go to school, learn them. But once you get into the field and you're practicing, there's just a plethora of materials, different types of engineering solutions that, you just cannot possibly cover in school, you know, I mean, and but as long as you understand the concepts of how you would go about designing and the fundamentals behind it, you can apply it to really most engineering solutions, you know, and just that experience that you gain over time doing project after project, that's where you really fine tune it. And some people can get kind of more focused on one particular area of that field too, you know, just because they've done so many of those projects and that experience built up. But I mean, it all starts with, you know, the research, you know, and just really getting in there, and having mentors too that have been through it are absolutely critical. I mean, I just don't limit knowledge of any kind. If it's coming from mentors, if it's coming from, you know, codes, textbooks, you know, regs, you know, people, you just got to open up your mind to all of it, you know, and take it all in and utilize it. So.
Yeah, one of the things that I've found in my career is that, you know, the government can generally be pretty slow in making major innovative moves. And what that generally comes down to is the manufacturers of products are generally on the leading edge of things. I mean, you'll have R&D at universities and things like that, you know, will develop, you know, with manufacturers or developers, develop patents for new products and things like that. And then those people are the ones that engage with industry or construction industry, design or construction, and they will start to integrate into those conditions for developing submittals and things like that. And then what happens is, as we in the government design see those submittals with that innovative product data come across our desk, we're like, well, this is actually a really great idea. Let's consider this maybe for a future project. And so rather than specifying the you know, by title, we'll look at the salient features, the characteristics of what that may bring to the condition of design, and we can specify those. But that's kind of how the innovation line kind of trickles down to the design engineering that we do.
So when why work for the Corps as opposed to industry? Why come work for the Corps?
I know for me, public service has been paramount. The idea that the work I do every day really helps the public, and I'm, budgets, schedules, quality are the three general aspects of any project. They always say you can have 2 of 3, so pick your 2 or 3. 2 of 3. For us, we're always, considering budget, because money is finite, and we want to make sure that we don't go over budget. However, profit is not generally a part of our budget, like it would be in industry. And so at the end of the day, industry, design firms, contractors, that kind of thing, they ultimately have to make a profit so that they can stay in business. We are not generally subjected to that. So that means that we can generally spend just a little bit more time focusing on maybe the quality a little bit, so that we can reduce modifications during construction. We can improve the quality of the system we're putting in place. Again, subject to a budget, but not necessarily subjected to profit.
And I remember you're from the Manford area, right? Or your dad?
My dad is, yeah.
Your dad lives in
Yep,
Manford,
yep.
and you were working the Keystone Dam.
Correct, yep.
The bridge.
Yep. So was
Bridge
Daniel.
deck.
Yep.
Oh, okay.
Daniel did the
Both
design
did.
on the bridge. Yeah.
Okay.
Yep.
And you talked about that,
Mhm.
about you're sort of making the bridge deck better
Right.
for people who even for you.
Even for me, yeah. I was out there last weekend. So
Were you really?
Yeah, and so getting to drive across that bridge on 151, you can really tell that there was a lot of energy and a lot of heart put into the design of that project. And then there was also a lot of energy and heart put into overseeing the construction of that project, because you can have a near perfect design, but if it's not if the construction is not overseen well, then it doesn't matter. And so it really, that project for me in particular is a testament to a great design and a great construction oversight.
And I mean, a bunch of cyclists went over.
Yeah,
there
exactly.
2 weeks
Yeah,
ago,
yeah.
so-
The Iron Man. Yep,
Yeah.
yep. So
So I mean, it was probably good that they weren't hitting potholes. And
yeah,
stuff.
exactly. What about you, Jeff? What motivates you to stay at the Corps and be a part of the production center?
I think the biggest thing is being able to be involved in big projects that matter, and being involved with the Corps versus a private industry. When I was looking at coming out of school and having the choice between private industry, government, I always thought, when it comes to the biggest, most critical designs, we're going to trust, on a dam, for instance, we're going to trust that to, the Corps and not a private contractor. And I wanted to be involved in big projects that matter, that I could really sharpen my technical toolbox and learn from the best, be involved with, leaders in the field and world-renowned experts. That's why I leaned with the Corps.
Daniel, what about you?
Yeah, I mean, it boils down to the projects, like Jeff said, and we have so many different types of structures, in the Corps, and so from a structural engineer standpoint, we do a lot of different things. I mean, we have, as you mentioned earlier, Milcon has vertical construction, horizontal construction all over, and in the civil works arena, and now that we've made kind of our dam safety production center expertise as well, we focus strictly on dams, but within the dams, there's, all types of work for that as well. There's wall systems, I've got to work on bridges as well, which it's been a big part of me as well. So it's, whenever you get outside, you're more specialized. You
don't get pigeonholed.
Yeah,
In the
no,
Corps,
you
you
don't.
get
You
pigeonholed
don't.
as an engineer.
And what I hear too is whenever you're in some engineering firms, you kind of have to stay within that, in that stronghold of whatever that specialty is. you can't really branch out at all. And so
You guys practically have to.
you have to here.
Yeah.
You have to be like my first mentor. He called. He said he was a jack of all trades because, you know, and I didn't really understand it, you know, but as I've progressed throughout my career, it totally makes more and more sense every day because you do not totally utilize all the disciplines you learn in school, except maybe here, places like here. I'm a structural engineer, but I've had to relearn other parts of my civil engineering background that didn't necessarily fall under my discipline, because you have to understand some of these other concepts and how what you do affects other parts of the, other parts of the structure, and you get to do that here. If you're in private, different parts of that engineering work would be contracted to different groups. And okay, you have this firm do this part of the design. You have that firm do that part of the design. Here it's like, we pretty much usually we take it all on ourselves. So
there's a lot of specialization
absolutely
out there.
Yeah, absolutely.
And there's nothing wrong with that.
No,
it's just
no.
And that certainly specialization has its
Right.
benefits,
Right.
but I think you guys get. I talked to someone in the military about this years
Right.
ago. It was a nurse, and she was telling me kind of the same thing about nursing in the military. And she was saying, in the military, I'm not going to just do obstetrics, or I'm not going to just do, ER. I'm going to do everything, and that's nice, especially if you like doing different things as opposed to, and I'm not saying that anybody in the private world just gets going through the motions, but you certainly, because even in specialization, there's I guess different aspects. It's not like putting doors on a car.
No.
You're at least getting different shapes. So
Absolutely.
So you're structural, you're geotechnical. Adam,
I'm civil.
Civil. Okay. So let's talk about the difference between those three areas, and I'll kind of get this closed up because I don't want to hold you up any longer. I know you've got important stuff going on. But when you say civil straight up, what does that mean for in terms of the Corps at least?
So the way that and my dad's is also a civil engineer, and my grandfather was a chemical engineer. And so I've had, and also my father-in-law is a mechanical engineer. So I've had experience around engineering my whole life. The civil engineering, general site civil, I equate to kind of the architect equivalent of a project. So we are, really responsible for coordinating with geotech on slope design for, say, an embankment. We're responsible for coordinating with structural, say, for excavation for a new structure and backfill. There's a lot of details that would go into transportation, water resources, design of channels, design of site grading, coordinating with environmental on making sure that any hydroseeding or turfing isn't going to be influenced negatively onto existing infrastructure. There's a lot of aspects to the civil realm that I'm responsible for throughout the course of design, and those are the aspects that I equate to the civil realm. So
Jeff, what is geotech?
Well, first and foremost, as a geotech, you're a civil first. Civil and structural and water resources, they're all kind of stemmed out of, it's a specialization of a civil engineer. But a geotechnical engineer would be specialized more into soil interactions, groundwater, foundations, basically how how the earth is going to affect the structure, the embankment, that sort of thing. And I'll work closely with a structural when we're building, like for instance, a retaining wall, as far as letting the structural know what kind of soil interaction we're going to be having at the site, what kind of rock we have present, the strength of those materials, so that he has the proper parameters to put into his design. And then also work closely with a civil to kind of, learn what the limitations of the site may be, and, so that's kind of where I see a geotech.
In this part of the country, you guys, it's a lot of clay soils, right? Really clay, sedimentary rocks. And do you see a lot of granite? Do you see much granite at all, or?
Not generally in Oklahoma.
I know we have a quarry that produces it because
Yeah.
we use it for a lot of our embankment jobs. But no,
Yeah.
you don't see a lot of that. But for instance, I'm involved right now with another project out working with in a dam on California, and you see more, not karst. I worked on another project that had karst up in Kentucky.
That
They
have
use
what?
Karst geology, which is like limestone, caves,
Oh.
sinkholes. But out in California, you see seismic, which is a whole different realm of geotech and structural. So
I mean, we've had some quakes here, or at least
Right.
we felt in our region.
Right.
And is that something that you have to like take into account a lot of here, or for the most part, because they're so deep and far away?
No, it's impacted. I
Mhm.
think it's impacted what we do. I mean, I take for example, you've heard of Can Lake,
Mhm.
and I was the lead engineer for that project for part of its life.
And real quick,
Right.
a quick rundown of what that project was, because
Yeah.
you've got the what are they, surge gates or whatever they're called?
Fuse gates.
Fuse gates, my bad. Yeah.
Yep. So it's a big lake system, part of the Canadian River system, and it's a lake that primary for flood control and Tanner Gate spillway, and you have also an emergency spillway that will release for a PMF flood type of event. For the
PMF
fuse
stands
gate.
for,
Probable maximal floods.
and that's a
maximum.
lot. Like,
That's a lot. The PMF it varies sometimes the frequency that's associated with it. But yeah, you know how floods, that's typically used. The frequency is talked about. Once in a how many year event, right? And
which
so-
does not mean you're going to get that once in a
no, it doesn't necessarily mean that.
You can
It's
get
just-
500-year
yeah,
events in a row.
It's just
yes.
the high likelihood, the
But you-
likelihood of it. But,
Sorry, I got
No,
you
it's
off.
okay,
But
that's
just
okay.
So that
But-
project.
But that project specifically, it was in that area, that mid of Oklahoma. We've experienced induced seismicity, over the years, and it's from various sources they argue about the source of why that induced seismicity occurs, but nonetheless, I mean, it's been shown. We had to deal with that whenever we were doing a final risk assessment. As part of the dam safety process, you do risk assessments and you analyze, probable failure modes and so forth, and what that risk translates to in terms of, what's the safety of that dam, right? And during the process of that project, the years of when we were, improving and modifying that dam to handle that PMF flood, induced seismicity became an issue throughout the project, and the risk assessment team had to assess that induced seismicity as it relates to, how it could make the dam fail, and so we actually were directly impacted by that, and luckily, they did the analyses to show that it was still safe, but yeah, absolutely, it's impacted that. And as a matter of fact, from a structural engineering standpoint too, when we designed for the seismic load case too, I mean, those tables, we use maps that show accelerations. I mean, those have been updated to reflect induced seismicity. So yeah, I mean, they are impacted because codes always change, and for a structural engineer, like part of what we do is we design structures to handle loads and to stand up basically and not fall down, right? And part of what we do is we look at codes to tell us, hey, this is safe to do this. You design it for these types of loads. You design it for these types of failures, and as long as you adhere to that, then you have a safe structure, right? And low probability of failure. And so similar to that, like you have the induced seismicity. Well, that's over time, it's actually impacted our codes and the recommendations in our codes. So yeah, I mean, those things happen, and I think overall in the engineering profession, as failures happen, they also help to give us, newer guidelines on what we need to be doing instead of what we did in the past. And that's a big part of, engineering in general, but especially dam safety too. Like, you know, it's always evolving, and you know, and we're always learning. Hey, these are the details. These are the things you want to incorporate into your new designs, because we've proven that they are safe. You know, they're better, and so
You're
it's
getting
always
new.
changing.
You're getting new data.
Absolutely.
Essentially,
Absolutely.
like it's like with
It's always changing.
with any project.
Yeah.
When we update, I guess when we start doing dam safety modification type
Right.
studies or whatever, right? Like
Yeah.
people will say, well, why now are you adding? Well, why now would you
Yes.
want to potentially have this as a
Change
TMF
this.
or whatever?
Right.
Right.
And well, we've seen over the
Mother
years that
Nature's changed.
that data
Exactly.
has
Yep.
increased. We have
Absolutely.
more data, right?
Absolutely.
So like,
And Mother Nature's changed. Like,
Right.
you know, we're at the whim of Mother Nature. I mean, what
Mhm.
we do, we're trying to design structures against flooding, right? That is continually changing over time. And so, you know, the hydrology behind determining those floods, well, they're going to change too. I mean, if we get more flooding historically, then guess what? It's going to impact and trickle down to, hey, what we have to do to assess those structures and keep
Yeah.
them, you know, maintained so that they can handle those floods. So it's always evolving.
Yeah, it's kind of like, you know, we don't teach our children the same way we were taught 40 years ago.
Right.
You know, education standards have changed as a result of
Right.
new data.
Yeah.
Engineering standards change as a result of new data.
Right.
And
Yeah.
the part of the challenge is that regulations take a while through the approval process to really come
Catch
down
up
to the
with the
working
data.
level.
Yeah.
But because of, again, networking relationships, we can be aware of what those pending changes are and try to be on the forefront of implementation without violation so that we can make sure that any of the new designs we're doing accommodate, you know, emerging standards while still complying with the current guidance. So
and just to reiterate on Canton, you didn't see any physical impacts to the structure from any earthquakes or out.
No, exactly.
So like that's
right.
another thing.
Yeah,
Like
absolutely.
like, I mean,
the instrumentation part, the monitoring.
Right.
You know, like the Tulsa District Dam Safety Group, we have all this instrumentation that they have to continually read, keep track of, and monitor the dam. So they know they can safely say, hey, there are no issues, right?
Right.
And we have, they have the instrumentation to prove that. And so that's why it's so critical, because whenever our structures, they can impact the lives of many people here. We're talking about very serious consequences, and Canton was is one of our dams in that way, because the consequences are so high. And so absolutely, we're not going to take any risks. We want to do everything in our power to really understand what's going on with our structures, the embankment, the spillway. And so absolutely, I mean, but we utilize that. Dam safety does too.
have you ever been tasked with being one of the guys that has to go out and do the inspection after a seismic event or something? Because I know we have like those
right.
guidelines where it's like within
Yes,
10 miles,
thresholds,
within
yes.
30
Yeah.
miles or 50 miles.
I think all structural engineers have taken the turn on that. I think I did at one time, because it happened. Like I said, the induced seismicity. It's gotten, it's just become an issue in central Oklahoma more so over the last 10 years or so or whatever. So it impacts what we do for sure. And so that's part of what I think too is the interesting thing about engineering is Mother Nature changes and conditions change. They always do. And trying to adapt to what they are, it's interesting. It never is dull in that way.
Especially when you've got a structure that's got a design life of, say, 50 years
Yeah, there
or
you go.
75 years.
Exactly.
And
right.
then you're trying to think,
Did they think about that stuff then,
Right,
or
exactly.
did they have any idea? That's part of the interesting part. Like what did they design for, right? And if they didn't design for that, well, what do we have to do? What are we obligated to do to keep the public safe? And that's where a big part of dam safety modifications comes in. That's part of what we do is, hey, well, if we find out that a dam is no longer, safe for these conditions, well, we have to upgrade it, like you would anything else. You would upgrade it and modify it to handle those new conditions, so.
Yeah.
Does soil change over time typically?
I wouldn't say that soil would change as much, but our understanding and the tools to model the soil have definitely evolved.
good.
You know, we've been geotechnical engineering as as an art. You know, basically we've been doing geotechnical engineering as long as we've been building things. But the study of geotechnical engineering, really with Terzaghi, has been like a 20th century and later process. You know, it really didn't become a field until
What Terzaghi, is that a person or is that a
person.
Oh, and can you, who is that?
Kind of the
Carl
godfather.
Terzaghi, he's
of-
like considered the father of geotechnical engineering. The actual study of it was, you know, really going. I think it was the 1940s, if I'm not mistaken, is when a lot of like the mathematical principles started to be developed. A lot of these things may have been known by humankind, kind of as an intuitive thing, for millennia, but we really didn't put math to it until then. And then you talk about computer modeling, where I can run 10,000 simulations of a slope in a few minutes, whereas it may have taken someone 25 years ago hours to run one or two of those.
Because they were using slide rules.
Yeah.
Yeah.
And, you know,
Hand sketches and
All hand
things
calculations.
like
so,
that, yeah.
you know, that may allow us to identify things now that we may not have seen then, or to analyze things differently, to use Monte Carlo analysis, where we can vary properties according to statistics versus just picking one set of parameters to run.
Yeah. Yeah.
So he started studying, and this was like something that they just kind of took it for granted. They just kind of, I don't know, you said intuitively, they sort of based on experience.
Experience.
Yeah.
In essence, would have been, you know, like the Romans would have. Let's build a block this size, you know, by this size, and we'll use it with this source of mud or material in order, because it's always worked that way, you know, and like what he was saying, what Terzaghi did was evaluate, okay, why is it like that? What are the testing conditions for that material, and what are the parameters that result as you know, a result of, you know, compaction methods, or, you know, saturation conditions, and those kinds of things. And you can, now we have the tools, like Jeff was saying, to really quantify what all those intuitive conditions were in the past.
All right. Thank you, gentlemen. I really appreciate your time. And is there anything I didn't ask you, I should have asked you?
So I always, anytime I'm presenting to like students, I always present two things. Number one, find the intersection of your passion and your talent. That's the sweet spot. Okay. Number two, impact. The work we do means something. It impacts people. And, you know, you hear a lot of accolades through other industries like health, law, finance, things like that. And you don't always hear those same considerations for engineering. What I would, you know, have people consider is that doctors and lawyers generally represent one patient or one person at a time. Engineering generally represents millions at a time. And so our impact is felt across the world, regardless of where you're located. So just consider that any of the projects you're working on deserve your full attention, your high quality, and your focus and energy, because you impact thousands and millions of people every single day.
We hope you've enjoyed this episode of Corpstruction. This show was written, edited, and produced by Brannen Parrish of the Tulsa District Public Affairs Office. Find us online at www.swt.usace.army.mil. You can find us on social media, usually at USACE Tulsa, all one word. Have a great day.